This is the next problem of the particular type. So what type are we looking at? We are looking at the type where, so there are two trains, correct? And two trains are moving in what direction? It's there here, isn't it? Let's look at this particular question. See, the distance between two stations is 300. Speed of one train is 60, the other is 25 meter per second. The distance covered by the slower train before they would meet, right? Now here in this case, both of them are moving in the same direction, all right? So that would be the case where we are going to look at it. And you can also take it that the distance between the stations, so you might also say that they're in the opposite direction. That's also one of the cases, all right? So in this case, what we have two stations A, you have another station B, and then this distance is 300, all right? One train, the slower train starts from here. This is the slower train, and the faster train starts from here. All right. Now, first we need to see which is the slower one, which is the faster one, right? Now, 60 kilometer per hour. So we'll call it as S1, 60 into 5 divided by 18. All right. So we can take it in terms of 6, 10 times, 3 times. 50 by 3, 50 by 3 meter per second. So the slower train is going at 60 kilometer per hour. Fair enough. You can either do this way, or you can convert the 25 meter per second to kilometer per hour, which would be a better option if you ask me. I mean, it's up to you. Whichever you feel easier and comfortable, you guys can do that. So when you have 25 meter per second, that's 25 into 18 by 5. This is 90 kilometer per hour. Okay. Now, both of them are moving in this particular way, correct? Now, the distance between them is 300 kilometer, right? Now, then it says the total speed, since they're moving in the opposite direction, it's going to be 90 plus 60, right? Which is going to be 150 kilometer per hour. Remember, we are looking at the relative speed between the two trains. The question says the distance covered by the slower train before they meet would be, correct? So calculate the time first, the time at which they are going to meet. So time formula is what? Time is equal to distance upon speed, which will be nothing but 300 divided by 150. That's 2 hours. They're going to meet after 2 hours, that's all. So what do we have now? So we have the time to be 2 hours. So the slower train is going to travel for 2 hours before it's going to meet the other train, the faster train. We know the speed. Distance is equal to speed into time. For the slower train, we know the speed. Speed is how much? 60 into 2. That's 120 kilometer. So the slower train is going to go for 120 kilometer before it's going to reach. Fine. This is how you need to solve these kind of problems.